Okay, so I forgot to start recording these notes right at the beginning. So quick overview of what I have here. I have a few different polynomials right here. And then what we did is we talked about what the degree of each was, the type of each one, and what the leading coefficient is. Degree we know from before is our leading or our biggest exponent. Oops, switch to red. This biggest exponent, the first one was a 2, so it's a degree of 2. We knew from last chapter that was called a quadratic. And then the coefficient on that term would be a 2, that's your leading coefficient. The next one was written out of order. Our biggest exponent was 4, so it's a degree of 4. And then that was a new type. If it's a degree is 4, we call it a quartic. And the leading coefficient is not necessarily the first coefficient, it's the coefficient that goes with that term. So its coefficient, if I rewrote this in the correct form, that would come first to be a positive 5. This one, degree of 3, which is cubic, its coefficient was 5. This one is out of order, but the largest exponent was 5, so degree of 5, which is quintic, and its coefficient was a positive 3. The last one, degree was 6. Anytime we get 6 or bigger, we didn't really have a name. You can just call it based off of its degree. So 6th degree polynomial, and its leading coefficient was a negative 4. All right, from there, I want to think about what some graphs look like of different types. And so the types we're going to look at, constant, which has a degree of 0. Linear, which is when your degree is 1. Then we have quadratic, where the degree is 2. And then we get into our new ones. Cubic, when the degree is 3. Quartic, when your degree is 4. And quintic, when it's 5. And I want to have just a real basic idea of what each of those graphs may look like. So constant, we've dealt with constant before. I don't know if you recall, but the graph of a constant is just a horizontal line. Linear is also a line, but it's going to be sloped. Quadratic, we know from last unit that that's just a parabola. And then the rest of these are new. So a cubic might look like this. A quartic might look like this. A quintic might look like this. And what you should observe is every time that I add a degree, we added another, what I would call a turning point. And what I really want to highlight is that next we're going to talk about end behavior, we call it. It's thinking about what's happening at the left end and at the right end. And if you look at these, I'm not worried so much about constant, but degree, your left end was pointing down, your right end was pointing up. Now, of course, it could go the other direction. But when you contrast that, or I go ahead and look at, let's jump to cubic. Cubic is something similar. I have the left end down and the right end up. They might be switched around. And then the quintic, they are switched around here, but the left end is up, the right end is down. All of those, the two ends are pointing the opposite directions. And then look instead at the degree of 2 and 4. Degree of 2, their both ends are pointing up. Or they could be pointing down like they are in the fourth one. They're both pointing down. We kind of start to notice a pattern based off of whether the degree is even or odd. We know whether both ends are going to point the same direction or opposite directions. We can summarize that here. So if it's an even degree, both ends point in the same direction. It's like both up or both down is what I mean by that. And if it was odd, the two ends point in opposite directions. And then I'm going to add to that something that's been true ever since you started graphing a couple years ago. This was probably never pointed out to you, but it does become important as we now get into polynomials. Your leading coefficient, which I have been and will continue to abbreviate as LC, leading coefficient, determines whether your right end points up or down. For example, think about y equals 2x plus 4. If we graph that, we'd go to 4, and then we do our rise of 2 over 1. What direction is the right end pointing? Is it pointing up or is it pointing down? It's pointing up. And our leading coefficient was a positive 2. But if we had a negative slope, it'd be going downhill from left to right, so the right end was pointing down when it had a negative slope. Same thing's true with parabolas. 2x squared plus 3, for example. The right end is pointing up. So you can use the leading coefficient to know what's going to happen to the right side of your graph. And so where we can go with this and where we're going to go with it next is we're going to talk about end behavior. End behavior, it's formatted kind of weird. Now, at first, when you first see it, probably won't make a lot of sense to you, but if you stop to break it down, hopefully it does make sense. But every one of these end behavior problems is going to start off like this. Okay, and so let me read these symbols to you, if you will. First line, as x, and then that arrow we would read as approaches. As x approaches negative infinity, f of x approaches, and I have a blank there, we're going to fill that in. And then the second one, as x approaches a positive infinity, f of x approaches something. Now this is end behavior. It's really, one of these is the left end and one of them is the right end of your graph. And if we think about a graph, the x-axis is the left-right one. And then your y, or oftentimes now we call it f of x, is your up and down. So when we say as x approaches negative infinity, what direction are we talking about? If we go on the x towards negative infinity, that means we're moving to the left. So that's a fancy way of saying the left end. And so then As x approaches a positive infinity, that would be the right side, or the right end of our graph. So we have to tell what's going to happen to the left side and the right side of the graph. And really, I'm talking about whether it's pointing up towards a positive infinity or whether it's pointing down towards a negative infinity. So couple what we just talked about right before I slid it over here. We talked about the degree and the leading coefficient and what that means about our graph. The degree of this problem is 3, which we know is an odd number. The leading coefficient also happens to be a 3, a positive 3 though, and positive is what I care about. So the leading coefficient, recall, tells you what the right end is going to do. So the leading coefficient is positive, so the right end is going to point up towards a positive infinity. So I can fill in that end behavior. The degree is odd. So we remember, once again from over here, odd degree, the two ends point in opposite directions. So since the right end is pointing up, the left end must point down. So it's going to point towards a negative infinity. So there is my end behavior of that function without even knowing what the graph looks like. Let's do another one where instead of giving you an equation, I give you a graph. This is probably a little bit easier, at least initially. So as x approaches negative infinity, we'll think about what f of x does. And then as x approaches positive infinity, we'll think about what f of x does. They're all going to start off that way, the left end and the right end. So look at the picture. Look at your left end. Where's your arrow pointing? Is it pointing up towards positive infinity or down towards negative infinity? Well, it's pointing up. So that means the left end is heading towards a positive infinity. And then look at the right end. The right end is also pointing up towards a positive infinity. So its degree was even. So that's how we deal with end behavior. The last thing that you're going to be asked about in this section is zeros. And specifically, how many zeros does the graph have? What's another word for zero? Could be an x-intercept. So how many zeros does the first one have? Follow your x-axis, it only hits it once, so it has 1 0. If we move to the right, 1, 2, 3, 4 x-intercepts, so 4 zeros. Look down. This one, no zeros. 0 zeros. And then 1, 2, 3, 3 zeros. All right, that should take you through enough information for you to be able to do the 5-3 assignment.